Rubber on the floor is required for protection from live parts when the voltage exceeds 150 volts to ground, and there is a possibility of persons standing on the floor or other conducting surface while touching the live parts. This requirement stems from the need to provide an additional layer of insulation between the worker and the ground, reducing the risk of electric shock. When a person comes into contact with a live electrical component, their body can become part of a circuit, allowing current to flow through them to the ground. This flow of current is what causes electric shock, which can range from a mild tingle to severe burns, cardiac arrest, and even death. The severity of the shock depends on several factors, including the voltage, the amount of current flowing through the body, the path of the current, and the duration of the contact. Rubber insulating mats are designed to provide a high level of electrical resistance, which significantly reduces the amount of current that can flow through a person to the ground. By standing on a rubber mat, a worker is effectively insulated from the earth, making it much less likely for a dangerous amount of current to flow through their body if they come into contact with a live electrical part. The 150 volts to ground threshold is a critical factor in determining when rubber matting is required. This voltage level is considered to be the point at which the risk of electric shock becomes significantly higher. Below 150 volts to ground, the risk is still present, but it is generally considered to be lower, and other safety measures may be sufficient. However, when the voltage exceeds this level, the potential for serious injury or death increases dramatically, making rubber matting a necessary precaution. The phrase possibility of persons standing on the floor or other conducting surface is also an important consideration. This means that the requirement for rubber matting is not limited to situations where workers are standing directly on the floor. It also applies to situations where workers may be standing on other conductive surfaces such as metal platforms, concrete floors, or damp surfaces. These surfaces can provide a path for current to flow to the ground, even if the worker is not in direct contact with the earth. In these cases, rubber matting is still necessary to provide an adequate level of insulation. The type of rubber matting required will depend on the specific voltage levels and working conditions. Different types of matting are designed to withstand different voltages, and it is important to select the appropriate type of matting for the application. The matting should also be regularly inspected to ensure that it is in good condition and free from any damage that could compromise its insulating properties. In addition to rubber matting, other safety measures should also be implemented to protect workers from electrical hazards. These measures may include the use of personal protective equipment, such as insulated gloves and tools, as well as the implementation of lockout-tagout procedures to ensure that electrical equipment is de-energized before any work is performed on it. It is also important to provide workers with adequate training on electrical safety procedures and the hazards associated with working with electricity. This training should cover topics such as the proper use of personal protective equipment, the identification of electrical hazards, and the procedures for responding to electrical emergencies. By implementing a comprehensive electrical safety program that includes the use of rubber matting, personal protective equipment, lockout-tagout procedures, and adequate training, employers can significantly reduce the risk of electrical injuries in the workplace. The regulations and standards governing the use of rubber matting for electrical safety can vary depending on the jurisdiction and the specific industry. In the United States, the Occupational Safety and Health Administration, OSHA, sets the standards for workplace safety, including electrical safety. The National Electrical Code, NEC, also provides guidance on electrical safety practices. It is important to consult the relevant regulations and standards to ensure that the use of rubber matting is in compliance with all applicable requirements. The selection of appropriate rubber matting involves several considerations. Firstly, the voltage rating of the matting must be adequate for the voltage levels present in the work area. Matting is typically classified by its ability to withstand specific voltage levels, and it is crucial to choose matting with a rating that exceeds the maximum voltage to which it may be exposed. Secondly, the size and shape of the matting should be appropriate for the area in which it will be used. The matting should cover the entire area where workers are likely to stand while working on or near energized electrical equipment. Thirdly, the matting should be made of a durable material that is resistant to wear and tear. The matting should also be slip resistant to prevent workers from slipping and falling. Fourthly, the matting should be properly installed and maintained. It should be placed on a clean, dry surface and should be free from any holes, tears, or other damage. The matting should be regularly inspected to ensure that it is in good condition and that it is providing adequate insulation. In addition to its use in industrial and commercial settings, rubber matting is also commonly used in residential settings to protect against electrical shock. For example, rubber mats may be placed in front of electrical panels, washing machines, and other appliances to provide an extra layer of insulation. The use of rubber matting in residential settings can help to prevent electrical shocks, especially in areas where there is a risk of moisture or dampness. When using rubber matting in any setting, it is important to follow the manufacturer's instructions for installation and maintenance. The matting should be kept clean and dry, and it should be replaced if it becomes damaged or worn. It is also important to ensure that the matting is properly grounded to provide an effective path for stray currents to flow to the ground. Grounding the matting can help to prevent the build-up of static electricity, which can also pose a safety hazard. In addition to its electrical safety benefits, rubber matting can also provide other benefits, such as reducing noise and vibration, providing cushioning for workers who stand for long periods of time, and improving the overall appearance of the work area. Rubber matting is available in a variety of colors and styles, making it easy to find a product that meets the specific needs of the application. When choosing rubber matting, it is important to consider all of the factors mentioned above, including the voltage rating, the size and shape, the durability, and the slip resistance. It is also important to choose a reputable manufacturer that offers a warranty on its product. By taking the time to select the right rubber matting, it is possible to create a safer and more comfortable working environment for employees. Furthermore, understanding the specific requirements of the National Electrical Code, NEC, can provide a deeper insight into electrical safety regulations. The NEC addresses various aspects of electrical installations, including grounding, wiring methods, and overcurrent protection. These guidelines contribute to ensuring the safety of both personnel and property. For instance, the NEC specifies the types of wiring methods that are permitted in different locations, considering factors such as environmental conditions and the potential for physical damage. It also dictates the proper sizing of conductors to prevent overheating and potential fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit, further mitigating the risk of electrical incidents. In addition to the NEC, other organizations such as the Institute of Electrical and Electronics Engineers, IE, and the National Fire Protection Association, NFPA, develop standards and guidelines related to electrical safety. These standards cover a wide range of topics, including the design and operation of electrical equipment, the installation of electrical systems, and the maintenance of electrical infrastructure. By adhering to these standards and guidelines, individuals and organizations can minimize the risk of electrical accident and create a safer environment for everyone. Electrical safety is not just the responsibility of electricians and electrical engineers. It is a shared responsibility that requires the cooperation of everyone who works with or around electricity. By understanding the basic principles of electrical safety and following safe work practices, individuals can protect themselves and others from the hazards of electricity. This includes being aware of potential electrical hazards, such as exposed wires, damaged equipment, and wet conditions, and taking steps to mitigate these risks. It also includes using personal protective equipment, such as insulated gloves and safety glasses, when working with electricity. Furthermore, regular training and education on electrical safety are essential for ensuring that individuals have the knowledge and skills necessary to work safely with electricity. This training should cover topics such as the proper use of tools and equipment, the identification of electrical hazards, and the procedures for responding to electrical emergencies. By investing in electrical safety training, organizations can empower their employees to make informed decisions and take proactive steps to prevent electrical accidents.